Hello, dear students, and welcome to the fourth session of probability. Today, we are going to discuss a very important topic. Suppose I say you have a company which is making a certain product. So, your company is making cell phone covers. It has been made on, say, different machines, say machine 1, 2, and 3. And randomly, one day, when you check that, okay, this cover, you find it to be defective. What is the chance you know that it is a defective from machine 1 or machine 2 or machine 3? Why do I need this concept? Well, if you know that you're getting a defective from a certain machine, and if you rectify the machine or if you have a budget to replace the machine, the amount of replacements which are going as a complete loss, which eventually your company is paying it, will then lead to a profit. That entire concept we understand today on the lines of Bayes theorem, which is supported by law of total probability. Let me start this with an example. Suppose I say you want to select a student from your foyer whose name starts with the letter A. What will happen? You will first visit a classroom, and from the classroom you will select a random student, and then you check whether that person's name was starting with A or not. So your step number one is to select a classroom and a lot of students from there. So I am saying, suppose there are divisions E1, E2, E3, and so on up to En. Do you look at this diagram and understand that E1, E2, and En are mutually exclusive and exhaustive? What do I mean over here? The student who is in division 1 is not enrolled in division 2. Who's in division 2 is not enrolled in 3 and hence not enrolled in N. That means there is nothing common between E1, E2, E3 up to En. That means they are mutually exclusive. And when I bring them together, they add up to my full sample space, means they are exhaustive. What does this imply? Intersection is a null set, union is a sample space, hence the total probability of E1, E2 up to En is 1. Okay, you are interested to get a student whose name starts from the letter A. Look very carefully. Can I look at this part, students, and say this is in itself a sample space in which you are interested to get this part? So, if I want to find the probability of selecting a student whose name starts with the letter A, what will you do? You will first select division E1. What is the chance of selecting division E1? And you get a student whose name starts from A, given that he is from E1. Or you select division E2 and get a student whose name starts from A, given that he is from E2. So on up to you select division En and you get a student whose name starts from A, given that he's from En. This is my total probability of getting a student whose name starts from the letter A. This over here we define as law of total probability. I repeat again, what is the total probability of A taking place? You select E1 and get A from E1. Or if you recall, when I say and, I multiply. When I say or, I add. Or select E2 and get an A from E2. or select E3 and get an A from E3, up to select En and get an A given that is from En. This is your total probability of getting A. Okay. Can I also write this in the form as probability A is summation probability EI into probability A given EI, where I can go from 1 to up to n. So I have written the above example in the form of a summation. Summation means to add. Add putting I as 1, then add putting I as 2, then add up to I going up to n. This is your formula for law of total probability. Now, suppose I already have a student whose name starts from A. What is the chance he came from division 1? I repeat, I already have a student whose name starts from A. That means probability I already have someone whose name starts from A. Given that it starts from A, what is the probability he came from division 1? So, if you recall a conditional probability, our probability for A given B was probability A intersection B upon probability B. I am using my Bayes knowledge. This over here will be E1 intersection A upon probability A. Wait, I already found A. I already found A. That was my denominator. My denominator is select E1 and get A from E1, or select E2 and get A from E2, so on up to select En and get A from En. This is my total chance of A happening. What is the chance it was contributed by E1? That is simply this particular part. That is probability of E1 into A given E1. So it is very important over here that you first define your E1 up to En. Let us understand again. E1, E2, En students, it is mutually exclusive and exhaustive, means nothing common, adds up to 1. They are partition sets. So a probability that adds to 1 or a data that adds to 100 is your hint number 1 to be E1, E2 up to En. My major hint number 2 is the step 1 of your exercise. Step 1, select a machine, then select a product. Select a bag, then select a ball. Select a particular group, then get a particular person. Step number 1 is your E1, E2, En. That will always add to 1 in probability, and percentage will be 100. So understand this concept of law of total probability and Bayes theorem, and then we will explore the sums based on the same. So take a recall with this. If you want to avoid missing on such important concepts, like and subscribe to the channel to get regular videos of such important topics. Let us explore the sums now on the same. My first sum says 3 machines E1, E2 and E3 in a certain factory produce electric bulbs, which is 50%, 25%, 25% respectively of the total output. It is known that 4% of the bulbs produced by machine E1 and E2 are defective and 5% of E3 are defective. So you know what production is happening. You know the contribution of the production. If one bulb is selected at random from the day's production, calculate the probability that it is defective. What is the chance you get it to be defective? Okay. Next part, Knowing it is defective, it came from a certain machine. So first, what is the chance of getting defective? What is the chance of getting a student whose name starts from A? First, you visit the classroom. First, you visit the machine. So hint number one is select the machine. Then look for the defective. Here, my total production is from the three machines adding to 100. Hence, I define E1 is select machine 1, E2 is select machine 2, and E3 is select machine 3. Now understand everyone. My probability of selecting machine 1 is it does half of your production. It does 50% of your production. My probability of selecting machine 2 is 25%, and my probability of selecting machine 3 is the other 25%. This adds to 1. Now, what is your interest area? Example, getting a student whose name starts from A. Here, getting a defective product, a defective bulb. Okay, so I define D is select a defective bulb. Now, how many bulbs are coming out to be defective? Your machine 1 gives you 4% and machine 2 also gives you 4%. So, probability of defective given it is from machine 1. Probability defective given it is from machine 2. Probability defective given that it is from machine 3 is given to you as 4%, 4%, and 5%. Okay. Now, what can happen if you want to get a defective? You will visit machine 1, select a product, is it defective or not? Or you will visit machine 2 and get a defective from machine 2, or you will visit machine 3 and get a defective given it is from machine 3. Means I have to multiply these two values. Hence, my other value over here is probability E1 into probability D given E1, probability E2 into probability D given E2, probability E3 into D given E3. Students, this is your first sum, so we are going very slow with the detail. So I multiply this 50 into 4, 200 upon 10,000. 25 into 4, 100 upon 10,000. 25 into 5, 125 upon 10,000. I will add all these values to get the defective. So 200 and 100 is 300 and this is 425. So 425 upon 10,000. My first question was, if one bulb is selected at random from a day's production, find the probability it is defective. So probability of a defective bulb, that is probability of D, is 425 upon 10,000. You have to make sure this goes in the least fraction. That over here becomes 17 upon 400. Means what? For every 400 bulbs which your company is making, 17 are defective. We are going to come back to this. Next, my question says, given that the bulb is defective, it was selected from machine 2. So, given that the bulb is defective, it was selected from machine 2. That means probability E2 intersection D upon probability D, which means this answer divide by the defective answer. So 10,000 gets cancelled. I have over here 100 upon 425. That is 4 out of 17. Next question says, given that the bulb was defective, it was not selected from machine 3. Not from machine 3 means from where? From machine 1 or machine 2. So, given that it is defective, it is not from machine 3 means it is probability E1 given D plus probability E2 given D, means it is from machine 1 or machine 2. That will come over here, machine 1, machine 2, divide by this answer. So that will be 200 plus 100 upon 425. That is 300 upon 425. That becomes over here 12 by 17. Wait, is there an alternative method to solve this? Can I recall this as probability of E3 not given D is 1 minus E3 given D. E3 is how much? 125. 125. E3 is 125 upon 425. So 1 minus 125 upon 425, that is 1 minus 5 by 17, which I am writing here. 1 minus 5 by 17 gives me 12 by 17, the same answer. Which method should we use? Whichever you are comfortable with. You define the steps and you solve the method. Pause. Why is Bayes theorem important? Can I know for every 10,000 production which you are doing, 425 are defective bulbs? Means for every 400 bulbs that your company makes, 17 bulbs are defective. That means what? When you sell 400 bulbs, 17 are coming back in your replacement. That means you have to return 17 free bulbs to your supplier or to your clients. That means 383 is which is giving you an income, 17 is a pure loss. Think from a person who's running a company, students. Will you make a loss? No. What will you do? You know your average defective, which is coming in a replacement theory here. You will increase the price of the bulb so that your replacement cost is covered. That means your 383 bulbs which you sell will cover up the cost of the 17 defective bulbs. This means what? If you have the finance to replace a machine of E1, E2, E3, the replacement of the machine will lead to less defective. Now you've already revised the price. When you reduce the defective, that means your replacement has dropped. That is again your pure profit. Understand where my Bayes theorem is used. I know my total possibility of getting bulbs from 3 machines. I know how much defective I am getting. So my contribution of defective is maximum from where? If you look into this, for every 10,000 bulbs, you have 125 defective, 100 defective, 200 defective. Your maximum defective is from machine 1. So if you have the money to replace the machines, you will first replace machine 1, followed by machine 3, and then by machine 2. Don't just merely solve the problem, understand the crux of it, and after that maths will never be a challenge. Let us look into sum number 2. My sum number 2 says a fair die is rolled, die 1 to 6. If 1 turns up, a ball is picked up at random from bag A. If 2 or 3 turns up, ball is picked up from bag B, otherwise from bag C. Pause. You have 3 bags. You have bag A, you have bag B, and you have bag C. If you get the number 1, you select bag 1. If you get the number 2 or 3, you select bag B. If you get the number 4, 5, 6, you select bag C. Now let us see what is in the bag. Bag A contains 3 red and 2 white balls or marbles or whatever. Bag B contains 3 red and 4 white. Bag C contains 4 red and 5 white. A die is rolled, a bag is selected, and a ball is drawn. Find the probability that a red ball is drawn. Pause. What is your interest area? Your interest area is to get a red ball. Okay? So, please understand what is given to you. You first select the bag and then draw a ball. To select a bag, you first will roll a die. Depending on what you get on the die, you'll select it over here. So what is given to you, students? Can I say E1 is select bag A, E2 is select bag B, E3 is select bag C. You will get bag 1 when you get the number 1. You will get bag B when you get 2 and 3. You will get bag C when you get the number 4, 5 and 6. Okay. So first you select the bag. Then your interest area is to get a red ball. So I am defining R as an event that a red ball is drawn. Okay. Now understand how are we writing this second sum. I am saying probability of selecting bag 1 is getting the number 1 out of 6. Probability of selecting bag 2 is getting the number 2 and 3. That is 2 out of 6. Probability of selecting bag 3 is 3 out of 6. Okay. Now you are interested to get over here a red ball. Now please watch. The die is rolled, a bag is selected, and a ball is drawn. Only one selection is happening. So probability of red given from bag 1, probability of red given from bag 2, probability of red given from bag 3. Okay. So the chance of me getting a red from bag 1 is 3 out of 5. The chance of me getting a red from bag 2 is 3 out of 7. And probability of getting a red from bag 3 is 4 out of 9. Now, if you know the process, we multiply these answers and we add them up. So, what do I have over here now? When I multiply them, I will have probability E1 into R given E1. That over here is giving me over here 3 by 6 into 5 is 30. 2 into 3 is 6 into 6 into 7. 3 into 4 is 12. 6 into 9. So if I want to, since I know over here my denominators are different, I can reduce them to a fraction. So I have over here 1 by 10. I have over here 1 by 7. And I have over here 2 by 9. Okay. What was this? This was probability of getting a red ball. If you want to write the multiplication symbol here, you will end up writing this as probability EI into probability R given EI. So when we add this value, this probability of red is turning out to be 293 by 630. So my probability of getting a red ball is 293 upon 630. My question is saying, if the ball drawn is red, find the probability it came from bag A. So given that the ball is red, it came from bag A. That means probability E1 intersection R upon probability R. That means the first answer divide by the total answer, that is 293 divided by 630, becomes into 630 by 293, and hence your answer over here is 63 by 93. Next, I say probability, given that the ball is red, it did not come from bag B. That means given that the ball is red, it did not come from bag 2. That is 1 minus E2 given R. That becomes over here 1 minus probability E2 intersection R upon probability R. I have a tendency of writing the one bigger to avoid my denominator getting extended and having a silly mistake. That gives me over here 1 minus E2 intersection R is this answer, divide by this answer. That means 1 by 7 divide by 293 by 630 is 630 by 293. So 7 goes over here 90 times. So 293 minus 90 is 203 upon 293. This is your possibility of not getting a red ball from the second bag. That includes your possibility of getting a red ball from the first and the third bag. Now look at this part, what I'm saying here. A commonly asked question. I'm asking you to make a tree diagram for this. How do I express this given information in the form of a tree diagram? So I am saying over here, if I remove all other informations which I've got in my sum over here, I am only considering the values which I have for E1, E2, E3 with R given E1, R given E2 and R given E3. So whenever you have to make a tree diagram, first you will have your decision box. Then since there are 3 events, you will have 3 branches which will come out, namely E1, E2, E3. So here I will have my probability of E1, probability of E2, probability of E3. Then you have a chance node which is giving you either you get a red or you get a non-red. Again a circle, red or a non-red. Again a circle, red or a non-red. So I am writing this as probability red given from bag 1, probability red given from bag 2, probability red given from bag 3. Now let us write the numbers which we have. My probability of E1 is 1 by 6. Probability of E2 is 2 by 6 and 3 by 6. Probability of red from bag 1 is 3 by 5. Probability of red from bag 2 is 3 by 7. Probability of red from bag 3 is 4 by 9. So this entire information is put over here in the form of a tree diagram. Now I go ahead to multiply these values. So I have 1 by 6 into 3 by 5, which is giving me over here 1 by 10, your first answer. Over here 2 by 6 into 3 by 7 is giving me over here 1 by 7, and similarly 3 by 6 into 4 by 9 is giving me 2 by 9. This value adds up to the chance of getting a red ball, that is 293 upon 630. We have expressed the same sum in the form of a tree diagram. Now, what is this other branch which is left? That other branch which we are talking about over here, students, is actually, if I say this was a red ball, so this branch is not a red ball, which in your bag is a white ball. So probability of not red from E1. So if red was 3 upon 5, not red is 2 upon 5. Probability of not red from E2 is 4 by 7. Probability of not red from E3 is 5 by 9. So if I would have gone to multiply that again over here, 1 by 6 into 2 by 5 will give me over here 1 by 15. Next, 2 by 6 into 4 by 7. That will give me over here 4 by 21. And 3 by 6 into 5 by 9 will give you over here 5 by 18. Students, note this value down will add up to 1 minus 293 by 630. Why so? Because you will either get a red ball or you get a white ball. So if my question says, given that the ball was non-red, it came from bag 1, so we are talking about this total over here. Okay, so when a tree diagram is expected, you are only required to limit up to the black part. The green part is not required. But if you know to make the tree diagram and if you define your events properly, you can solve any kind of a sum with all your required steps. Let us look into the next sum. My next sum says an urn contains 10 white and 3 black balls, while another urn or a basket or a bag contains 3 white and 5 black balls. So there are two different kinds of bags that you have. It says 2 balls are drawn from the first urn and put in the second urn, and then a ball is drawn from the second urn. Pause. Let us picturize this well. I have urn 1 which contains 10 white and 3 black. 10 white and 3 black. This is in your bag 1. Your bag 2 contains 3 white and 5 black. Okay, this is your bag 2. Now, 2 balls are drawn from the first and put into the second urn. 2 balls are transferred from bag 1 to bag 2. And then a ball is drawn from the second urn. You are selecting only one ball from the second urn. Okay. Find the probability that the ball drawn from the second urn is white. Your interest area is to get a white ball. Pause. Before getting a white ball, what do? You transfer 2 balls. What can the 2 balls be? The 2 balls can be both white or both black or one white and one black. So understand this part very carefully. You will first transfer two balls. That will change the count of the second bag. Based on the change, you have to get one white ball. So step number one is you transfer two balls. So what can the two balls be? It can be white. So two white transferred from 1 to 2, or two black transferred from 1 to 2, or one white and one black transferred from bag 1 to bag 2. So again, understand, probability of E1, probability of E2, probability of E3. Now students, this is a place where an error can happen. My statement in the sum said, everyone, two balls are drawn from the first urn and put in the second urn. They are put together. So here we use the concept of combination. We will later on do sums. When I say two balls are transferred one after the other, that will change the count. Or if I say two balls are transferred, if there's another kind of a sum where we are selecting in the end without replacement, so that we'll touch later. Right now, two balls are transferred. What are we saying? First one is two white. So how many white balls are there? 10. So out of 10, I transfer 2 upon 13C2. Next, two black balls are transferred. That is, out of 3, I transfer 2 upon 13C2. Next, one white, one black. Out of 10, I transfer 1. Out of 3, I transfer 1 upon 13C2. Now, even if you put this in the calculator, you may have different fractions. I would recommend have the denominator same. So when I talk about 13C2, when I talk about NC2, so 13C2 is 13 factorial, 2 factorial, 13 minus 2 is 11 factorial. What does my cheat code say? This is 13 into 12 into 11 factorial, 2 into 1 into 11 factorial. So break the above number by 2 and bottom number by 2. That means this cancels over here 6 times. 13 into 6 is 78. That means my constant denominator here is 78. So I will have over here denominator 78. Same trick we use for 10C2. Break 10 by 2. 10 into 9 and down 2 into 1. That will give me over here 45. 3C2. Break 3 by 2. 3 into 2 and down 2 into 1. That gives me only 3 by 78. 10C1 is 10, 3C1 is 3. That gives me 30 by 78. Pause. Are we correct? If this adds up to 1, then we are correct. So 45 plus 3 is 48 and 30 is 78. We are correct till here. Okay. Next, I move on to after the transfer, what has happened. Now I am interested to get over here a white ball. So I am defining W, get white ball from earn to. Okay. So if I say over here probability white, given that you transferred both white, probability white, given that you transferred both black, probability white, given that you transferred one white, one black. Now note, your composition of the bag has changed. Your second bag was 3 white and 5 black. Students, If you've transferred 2 white, this becomes 5 white, 5 black. If you would have transferred 2 black, which is E2, this will become 3 white and 7 black. And if you transferred 1 white and 1 black, then your count will become 4 white and 6 black. So now you are selecting only one draw. So probability of a white ball is 5 upon 10. Probability of a white ball is 3 upon 10, and probability of a white ball is 4 upon 10. How much ever I am tempted, I will not cancel the numbers. So I go for the multiplication over here. That means I will multiply EI into W given EI. So 45 into 5 is 225 upon 780. 3 into 3 is 9 upon 780. 30 into 4 is 120 upon 780. So when I add this part up, my probability of getting a white ball, my denominator remains the same. 225 plus 120 is 345. 345 with another 9 is 354. So my answer over here of getting a white ball is 354 upon 780. Are we very clear with this part? Understand and then go ahead. Can I cancel this part further? So 354 will go with the number 3. So I'm left over here with 1, 1 and 8. Divide by going with 3. This becomes 260. That means I am left over here with 59 upon 130. This is my least fraction. Now, my question says further, given that the ball drawn is white, find the probability balls of same color were transferred. Same color means both were white or both were black. That means E1 given W and E2 given W. So I am going to deal with these two parts. That is 225 plus 9 upon 354. That leaves me over here with 234 upon 354. And you can bring it to your least fraction here. So understand the previous case has changed the next answer, and hence your probability of getting a white ball has changed in this particular case. So understand this particular part, recall this particular part, and then we will discuss the next sum. Let us now look into the next sum, which has a little twist in the sum. Read it carefully. There are two boxes, box 1 and box 2. Box 1 contains 3 red and 6 black balls, whereas box 2 contains 5 red and n black balls. I do not know the count of n. My question says, so if one value is unknown, one value will be given to you in the sum. My question says, one of the two boxes, box 1 and box 2, is selected at random. Random means both the boxes have equal chance of getting selected, which is half. And a ball is drawn at random. The ball drawn is found to be red. I repeat, the ball drawn is found to be red. You already know it is red, means given that it is red. If the probability that this red ball comes out of box 2 is 3 by 5, find the value of n. Please understand what will happen first. You will select a box. So E1 is select box 1. E2 is select box 2. Okay, so my probability of E1 is half. My probability of E2 is also half. You are getting a red ball. So R is an event. Red ball is drawn. So probability of a red ball, given that it is from bag 1, is 3 upon 9. Probability of a red ball, given that it is from bag 2, everyone, red from bag 2 is 5 upon 5 plus n. Okay, what is my question saying over here? My question says the ball drawn is found to be red. Given that it is red, the probability it came from bag 2, that means I am given over here probability, given that it is red, it came from bag 2, is 3 by 5. That means I want E2 intersection R upon R. So let us first finish the table to get R. So if I multiply these values, will I have 3 upon 18? And when I multiply this value, will I have 5 upon 10 plus 2n? So probability of R is 3 by 18 plus 5 upon 10 plus 2n. If I take the LCM, will I have 30 plus 6n plus 90 upon 18 times 10 plus 2n, which comes over here as 120 plus 6n upon 18 10 plus 2n. We'll cancel the fractions later. This is your probability of R, the column total. My question says probability E2 given R is probability E2 intersection R upon probability R. This value is given to me as 3 by 5, which is this number upon the total number. That is 5 upon 10 plus 2n divided by this number, which is into the reciprocal, that is 18 10 plus 2n upon 120 plus 6n. So this 10 plus 2n gets cancelled. Okay, now I have to get this value of 120 plus 6n, which I'm throwing over here. So on the right side, I am left over here with 5 into 18 into 5 divided by 3. So 3 goes over here 6 times. 5 into 6 is 30. 30 into 5 is 150. So 120 plus 6n is 150. I'm writing it over here. 120 plus 6n is 150. So do I know 6n is 30 and hence n is 5. That means the number of black balls in this bag is 5. So this has gone reverse over here. A different kind of a sum using the same concept but requires your attention and your patience. So please understand this sum carefully. The next sum over here, again, a pick which I would really like this sum over here is read the question. Suppose, think from your perspective, you are solving an MCQ question which has 4 options and 1 correct answer. What can happen? In a test, an examinee either will guess the question or copy the question or knows the answer to a multiple choice question which has 4 options and 1 correct answer. The probability that he makes a guess is 1 by 6. The probability that he copies is 1 by 9. Now, the probability that the answer is correct given that he copied is 1 by 8. Find the probability that the student knew the answer to the question given that he answered it correctly. Pause. Too much information, but break down. What was a hint? A hint for E1, E2, En is step number 1. Imagine yourself, you are looking at a question. You look at an MCQ question, what is the possibility? Best option, you know the answer. Option number 2, you will guess the answer. Option number 3, you should not, but you will end up copying the answer. These are your 3 possibilities. And these are your mutually exclusive and exhaustive, which should add to 1. So hence I define E1 is an event that I'm going with what the question says, guess, copy, and knows the answer. So student will guess the answer. E2, student will copy the answer. And E3 is student knows the answer. Okay, please understand. Probability of E1, probability of E2, probability of E3. Now, in a test, an examinee either guess, copies, or knows the answer to a multiple choice question. The probability that he makes a guess is 1 by 6. The probability that he copies is 1 by 9. I do not know this value. But do I know total probability is 1? So hence will this answer be 1 minus 1 by 6 minus 1 by 9? 6 and 9 match to 54. So will this be 54 minus 6 minus 9 minus 6 upon 54, and hence this value over here comes to be 54 minus 15 is 439 by 54. This is your value here. I repeat, your total probability is 1. So I will say over here 1 minus 1 by 6 minus 1 by 9. The LCM for which is 54. So 54 minus 9 over here is 45 minus 6 is 39. Now, your main aim over here is to get the right answer. So C is that answer is correct. Now please understand over here. Probability of correct given E1, probability of correct given E2, probability of correct given E3. Now, what is E1? What is E2? Look over here. The probability that the answer is correct given that he copied. Copied is which one? E2. Correct given copy is 1 by 8. Okay? Other values are not there for you. Please understand, you are solving an MCQ question with one correct answer. So correct given that you guess the answer. You are playing a KBC students. You won that minimum amount, no lifeline. You're going to take a random guess out of 4 answers. You have the chance to be correct is 1 by 4. Clear? And correct given E3. E3 is when you know the answer. You know the answer. You're sure the answer is 1. So correct given that he knows the answer is 1. So your 3 values were given to you. The other 3 values you have to decode. If we end up multiplying these numbers over here, 1 by 6 into 1 by 4 is 1 by 24. 1 by 9 into 1 by 8 is 1 by 72. And 39 by 54 into 1 is 39 by 54. Okay, so probability of the correct answer is when you add all these values. So probability of C correct answer 1 by 24 plus 1 by 72 plus 39 by 54 will add up to 7 by 9. Next, my question says find the probability that the student knew the answer given that he answered it correctly. So probability given that it is correct, the student knew the answer, that is E3 intersection C upon probability of C. So E3 intersection C is this answer, that is 39 by 54 divided by 7 by 9 is into 9 by 7. So 9 goes over here 6 times. So this over here is 39, 7 6 are 42. That gives me over here 13 by 14. Get the interpretation, students. For every 14 answers answered correctly, 13 are the ones where the student knew the answer. So probability that student knew the answer given that it is correct is 13 out of 14. Let us look into the next choice. Again, a very simple question, but you have to decode it very correctly, so get the grammar in place. If a machine is correctly set up, wait, if a machine, if means condition, if a machine is correctly set up, it produces 90% acceptable items. Can I say, given that the machine is correctly set up, 90% of the items are correct? If it is incorrectly set up, only 40% items produced are acceptable. Okay, so if you set up the machine correct, you get an acceptable item. If it is not set up correctly, then 40% chance the item is accepted. Past experience shows 80% of the setups are correctly done. Pause. What can happen? Either you set up correctly or you don't. Your step number one is the setup and then the production starts. Does 90 and 40 add to 100? No. But 80, if it is correctly set up, 20% is a wrong setup. So can I say E1 machine is set up correctly and E2 machine is not set up correctly? Okay. Now, probability of the setup being correct is 80% and probability of setup is not correct is 20%. I'm cancelling the 0, I'm not cancelling the 10, easier for calculation. Next, if the machine setup is correct, it produces acceptable items. So A is item is accepted. Okay, so probability acceptable item given that it is correct, probability acceptable item given the setup was not correct. Now read the sum. If after certain setup the machine produces two acceptable item, this is my key statement here. I am not selecting one item and I'm saying acceptable or not. I am selecting item number 1 and then I'm selecting item number 2. Now, selection of 2 does not depend on 1. This is an independent selection happening over here. So, my question says you are selecting one item and then you're selecting the other item. This is an example over here of two selections happening, one after the other in this case. Okay. So, this will be two items are selected. Probability of it being acceptable is 90% if the setup is correct. So this over here will be 90% for the first item and 90% for the second item. That leaves me over here with cancelling the 0, 81 by 100. This is your key step. When the setup is not correct, only 40% of the items are accepted, means first item accepted and second item is accepted. So again the two zeros are cancelled. I have 16 upon 100. The probability of having an acceptable item over here is 81 plus 16 is 97 upon 100. My question says, if after certain setup the machine produces two acceptable items, given that there was an acceptable item, find the probability the machine was set up correctly. So given that there was an acceptable item, the machine was set up correctly, that is probability E1 intersection A upon probability A. That means the first answer upon the total answer, that is over here 81 by 97. For every 97 items which are accepted, 81 are because the machine was set up correctly. Please understand, this is 81 out of 100 and this is 81 out of 97 for the acceptable items. Let's look into the next sum. Three people, A, B, and C, apply for a job of a manager in a private company. The chances of them getting selected is in the ratio 1:2:4. That means these are the only three people who are coming for a job, and one of them has to be selected. The probabilities that A, B, and C, after their selection, will introduce change to improve profit for the company are 0.8, 0.5, and 0.3 respectively. Now read this very carefully. If the change does not take place, chances of them getting change is 0.8, 0.5, 0.3. Chances of them not getting change is 1 minus 0.8, 1 minus 0.5, 1 minus 0.3. That is the catch. If change does not take place, it is due to appointment of C. So please look over here very carefully. First, you have to select the person. So E1 is person A is selected. E2 is person B is selected. And E3 is person C is selected. Okay, so probability of E1 getting selected, E2 getting selected, and E3 getting selected. Over here it says 1:2:4. So total adds up to 7. So E1 getting selected is 1 upon 7, 2 upon 7, 4 upon 7. Now, if I say C is change in profit, there is a change in the profit for the company, okay, or an improvement in the profit, which is 0.8, 5, and 3. My question says change does not take place. So change does not take place because of E1. Change does not take place given that E2 was selected. Change does not take place given that E3 was selected. This is 1 minus 0.8, which is 0.2. 1 minus 0.5, which is 0.5, and 1 minus 0.3, which is 0.7. Please note, this is your important step in the sum. Now, over here, I end up multiplying these values. That means I am multiplying over here probability EI into C complement given EI will give me over here 2 by 70, 2 into 5, 10 by 70, 4 into 7, 28 by 70, which adds up over here 40 by 70. So probability of change not happening in profit is 40 by 70, which is 4 by 7. Now My question says, if change does not take place, it is due to appointment of C. So in this sum, let us students make a table for the base part that we were making. I am saying, given that change does not take place, it is for EI. So this will be 2 by 70 divide by 40 by 70 is 2 by 40. This will be 10 by 70 divide by 40 by 70 is 10 by 40, and this over here is 28 by 40. That means 40 times when change does not take place, 28 times is because of person C. 40 times when there is no improvement in profit, it is because of 10 times is because of E2, and 2 times the change does not take place because of person A. So you know who should your company hire. So my question, which was, given that change does not take place, it is due to person 3, which is 28 by 40, which I am writing it over here as 7 by 10. Okay. My question says, express this in the form of a tree diagram. So again, I will have over here the center box, which is my decision box, from which 3 branches will come out. That is E1, E2 and E3. That means select person 1, 2 and 3. After that, they will either bring the change or not bring the change. So probability change because of E1, change because of E2, change because of E3. I am saying no change because of E1, no change because of E2 and no change because of E3. My data over here is 1 by 7, 2 by 7, 4 by 7. The value here which I have is 2 by 10, 5 by 10 and 7 by 10. So when I multiply them over here, I will have 2 by 70, 10 by 70 and 4 sevens are 28 by 70, which is adding to your same value over here as 40 by 70, which is 4 by 7. So we've expressed the same sum in the form over here of a tree diagram. Let us look at the next sum, which says a girl throws a die. If she gets the number 1 or 2, then she will toss a coin 3 times. And note the number of heads which she is getting. If she gets 3, 4, 5, 6, which is your complement of 1 and 2, she will toss the coin only once and notes whether it is a head or a tail. If she obtained exactly 1 head, if means given that she got only 1 head, your required aim is to get 1 head. What is the probability that she threw 3, 4, 5, 6? Please understand, 2 possibilities. E1, you throw a die and get the number 1 or 2. E2, you throw a die and get the number 3, 4, 5, 6. What is my probability of getting 1 and 2? That is 2 out of 6, which is 1 by 3. Probability of E2 getting the number 3, 4, 5, 6 is 4 out of 6, which is 2 by 3. After doing this, you are going to throw a die. Okay? Sorry, you are going to toss a coin. I am saying If you get even, that is getting 1 or 2, you are going to toss a coin 3 times. On tossing a coin 3 times, what are the number of heads that you can get? So when you toss a coin 3 times, do you know you can get all 3 heads? Head, head, tail, head, tail, head, tail, head, head. That is 2 heads. Now 1 head. So head, tail, 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 head, tail, 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 head, and 0 heads. That means 3 tails. This is what can happen. Okay. Over here, when you get the number 3, 4, 5, 6, you are going to toss the coin only once. That means you can get a head or a tail. What is my interest area? My interest area is get exactly 1 head. So I am saying H is exactly 1 head. Okay. So probability exactly 1 head when she got the number 1 or 2 means exactly 1 head when she rolled when she tossed 3 coins will be over here. Exactly 1 head is 3 out of 8, and exactly 1 head when she tossed the coin only once is half. This is your main important part to decode the sum. Rest remains the same. If I multiply this, I have over here 1 by 3 into 3 by 8, and over here 2 by 3 into 1 by 2. This leaves me over here by 1 by 8, and this leaves me over here by 1 by 3. So if I add this part up, so probability of getting exactly 1 head is 1 by 8 plus 1 by 3, that is 3 plus 8 is 11 by 24. My question says, given that the girl got exactly 1 head, what is the probability she got 3, 4, 5, 6? That means E2. That is E2 intersection H upon probability of H. That means 1 by 3 divided by 11 by 14, 11 by 24 is 24 by 11. My answer over here is 8 by 11. So exactly 1 head occurs in 11 times of the case. 8 times of the case is because of the second part of throwing 3, 4, 5, and 6. Now look at these two sums very carefully, how the grammar changed the sum. P speaks the truth in 70% of the cases and Q in 80% of the cases. So when you go to the person P, either he will speak the truth or he will lie. Q will either speak the truth or they will bluff. In what percentage of cases are they likely to contradict each other? Means, first, if I say probability of P speaking the truth is 70% of the cases, and probability of Q speaking the truth is 80% of the cases. That means P not speaking the truth is in 30% of the cases, and Q not speaking the truth is in 20% of the cases. Everywhere I'm cancelling 1 0, keeping the denominator same for ease of calculation. My question said, in what percent of cases are they likely to contradict each other? P and Q contradict each other. Means what? I am P, you are Q, we toss a coin. We are not saying the same story. I am saying head, you are saying tail. We are contradicting each other. Means what? Possibility is I am saying the truth and you are saying a lie, or else I am saying a lie and you are saying a truth. We are contradicting each other. Means P speaks the truth and Q does not, or else Q speaks the truth and P does not. Does your answer depend on me? No. In this case, P and Q are independent. Now, when they are independent, intersection becomes the product. So this will be probability of P into probability of Q complement plus probability of P complement into probability of Q. This comes to 7 into 2 is 14. 3 8s are 24. That becomes 38 upon 100. So in 38 percentage of the cases, you and I, or rather P and Q, will contradict each other. Cut to, I say, in what percentage of cases are P and Q likely to agree upon the same fact? That means P and Q agree upon the same fact. That means P will speak the truth and Q will speak the truth. Both of us are saying head, means both are saying the truth, or both are speaking a lie. That means again independent. So the product probability of P is 7 by 10, probability of Q is 8 by 10, P complement is 3 by 10, Q complement is 2 by 10, 7 8s are 56, 56 and 6 is 62. This becomes 62 upon 100. That means in 62% of the cases, P and Q will agree upon the same fact. Pause. 38, 62 adds to 100. Why? Total probability is 1. When two people are talking about a head and tail, what is the possibility? Both of us will say the truth, or else both of us will lie, or else P will say the truth and Q will not. Q will say the truth and P will not. Means that has to add to 100%. So another way is, if this blue part, that means contradicting, was sorted, here you could have directly said 100 minus 38 is 62. That is an acceptable method. Jump to shortcuts when you get the basic clear. Now, keeping this grammar in mind, look at the sum. A man is known to speak the truth 3 out of 5 times. He throws a die and reports it is a number greater than 4. Find the probability it is actually a number greater than 4. Here comes your grammar in place. A man is known to speak the truth 3 out of 5 times. He throws a die and reports that it is a number greater than 4. What is your step number 1? You will throw the die. You will look at the sum and then you will decide whether you are speaking the truth or not. So looking at the die. So find the probability that the number is that it is actually a number greater than 4 where the person has reported that it is greater than 4. So understand the difference between the two sums. Okay. So I have to define E1, E2, which is my step 1 and my interest area. So I will first roll a die. So E1 is number greater than 4. E2 number not greater than 4. So probability of E1 number greater than 4 means 5 or 6. Number not greater than 4 is 2 by 3. Now R is an event that the person reports greater than 4. Okay. So probability reports greater than 4 given that it is greater than 4. Probability reports greater than 4 when it is not greater than 4. What are you saying? Reports greater than 4 given that it was greater than 4 means he is speaking the truth, which is 3 out of 5 times. Probability reports greater than 4. When it is not greater than 4, means he is saying a lie, which is 2 by 5. Why this sum is important? Because this also adds to 1 and this also adds to 1. So your E1, E2 is a fact, which is step number 1. You will roll a die, you look at the number and you decide whether you have to say the truth or a lie. Then if I go to multiply this over here, probability EI into R given EI, I will get over here 1 by 3 into 3 by 5 is 3 by 15. 2 by 3 into 2 by 5 is 4 by 15. That gives me over here probability of R is 7 by 15. What did my question say? He throws a die and reports it is greater than 4. That means if it is reported greater than 4, what is the chance it is actually greater than 4? That means when he's telling you the answer, is it true or false? That is E1 intersection R upon R. That means the numerator, first answer, divide by the final answer, that is 3 upon 7. Please understand the difference between the two sums. Commonly practiced and easier to know, but usually skipped. And then if there's a high possibility of this coming in the paper, a student can go wrong. Technical language, but if you define E1, E2 properly, you can easily crack the sum. Let's look into this part. My sum says, assume that the chances of a patient having a heart attack is 40%. It is also assumed that that a meditation and yoga course reduces the risk of heart attack by 30%. Meditation and yoga reduces risk of heart attack by 30%. And prescription of a certain drug reduces the chances by 25%. Get the grammar. At a time, a patient can choose any one of the two options with equal probabilities. That means he can either opt for meditation and yoga, or he can opt to take a certain prescribed drug. Any one of the two. That is your step number 1. It is given that after going through one of the two options, the patient selected at random sadly suffers a heart attack. So after taking these two, he or she still gets a heart attack. Find the probability the patient followed the course of meditation and yoga. Step number 1, patient opts for meditation or yoga. Step number 2, patient opts for a prescribed drug. What are the chances? Probability of a person opting for meditation or yoga over here is equal chances, equal probabilities. That means this over here is half and probability E2 also is half. Now, please watch this part very carefully. H is patient gets a heart attack. Okay, patient gets a heart attack given that he opt for meditation and yoga. Patient gets a heart attack given that he opted for a prescribed drug. Watch the grammar. Silly mistake happens is when we take the number. The grammar says it is assumed that meditation and yoga course reduces the risk by 30%. They reduce the risk by 30%. So chance of it happening is 70%. So this is 70 by 100. Now, taking a prescribed drug reduces the risk by 25%. the chance of it happening is 75%. Okay, so next I go ahead to multiply these numbers. That means probability of EI into H given EI. I am left over here with 70 upon 200 and 75 upon 200. That is adding over here to 145 upon 200. If I want the least fraction over here, will be 5 twos are 9s are 5 fours are 0s are. Okay, my question says, it is given that after going through one of the two options, the patient selected at random suffers a heart attack. Find the probability that the patient followed the course of meditation and yoga. So meditation and yoga is E1. So probability E1 given H is probability E1 intersection H upon probability of H, that over here is 70 divide by 145. So 5 14s are and 29s are. The only important part out here is to understand the grammar. The 40% over here is just to divert your thought, because that 40% remains constant to subtract in both the answers. So ignoring that, your answer still remains the same. Looking at these 11 sums, all types of sums for Bayes theorem and law of total probability are covered up over here. So watch them properly, understand the grammar. I again repeat, do not jump to direct answer. Define, interpret in simple language, then go for solving, and definitely your answers will be right. Your answers will be right. If you like the content shared, kindly subscribe to the channel and share it with your friends, which will act as a motivation for me to make more such lovely videos for you. Thank you so much and happy learning.